Hello, this is the Physics 211 VPython and Computational Physics Refresher mini course. My name is Greg Mulder and I teach physics at Linn-Benton Community College. In the Physics 211 General Physics with Calculus sequence, in every laboratory exercise we introduce a little bit of VPython programming and computational physics into each lab activity. The goal of this video is to help students new to Linn-Benton Community College become acquainted with VPython and a little bit of computational physics, or those students who are continuing on in Physics 212 to get a refresher. If we remind ourselves of what we did in Physics 211, the first half of the term we went through a series of labs that dealt with position, velocity, and acceleration, and a lot of the consequences of forces upon those types of motions. In this first video, we're going to look at how we used VPython to help analyze the position, velocity, and acceleration that we observed when dealing with a cart on a track in lab. The first thing we did when we started working with the VPython part of the laboratory is we downloaded VPython onto every person's computer. If you have a computer at home, you should sit down and try to do this right now. First thing we're going to do is we're going to go to the VPython webpage and start to download this free piece of software. So if you go to your favorite web browser, and type www.vpython.org, it'll bring you to the VPython programming page. VPython is an open source programming language. It's free to download, free to use. It's created by a set of physics instructors, and so it's an ideal type of program to do nice 3D simulations dealing with everyday phenomena. Once you're at vpython.org, go to the download page by clicking into the Windows link. And then down below, you'll see several options for downloading VPython. I'm going to suggest we download the Python and VPython version 2.7, as version 3 is a little bit new and still having the bugs worked out. Now notice that there's a couple things you need to do to get VPython on your computer. First, you need to download and install Python 2.7.1. You're going to download this program, as you see in the lower left-hand corner of the screen, and then you're going to install it. Now, make sure you install this program before you start downloading the second program. I'm going to go ahead and stop this, as I've already downloaded it. The second part is you are going to download and install VPython, and that's going to behave similarly. After you have downloaded and installed the VPython component, then we're ready to start opening the program and begin to work with it. Okay, so hopefully at this point you have downloaded both Python and VPython. The next step is to open up the VPython editor. VIDLE, or VIDLE, is the text editor used by VPython, or rather best used by VPython. When you downloaded VPython, you should have discovered on your desktop or on your program list a program called VIDLE for VPython. We're going to click into that now. And when we do that, we get this nice blank white screen. This is where we do all our programming. Now, the first thing we always do whenever we create a computer program is we initialize the computer. To initialize the computer, in this case, we're going to type the following. Follow along with me if you can. Type from visual import star. Star is the shift 8. Another way to say that is splat. What this line does is it imports everything from the module called visual. The star is what imports everything. And what is in this module are a whole bunch of routines that are going to make our life easier later on. The next thing we do when we create a computer program is we define our universe. By defining our universe, I mean we're going to show how big the universe is, what units it's going to use, and we're going to define all of our initial conditions. So here's what we're going to type. Try typing scene equals display, parenthesis title equals, and you can type here whatever you want, something like my first VPython program might be appropriate, or maybe you want to call it position, velocity, and acceleration, or lab 1 or something like that. Then type x equals 0, comma y equals 0. I'm going to explain what all these mean in a second, so go ahead and follow along with me. Keep typing across and type width equals 600 and height equals, let's try 600 too. Then type range, notice the range changed color there, equals vector, I'm going to do 3, 3, 3, and center equals vector 0, 0, 0. Okay, that was a lot to type all at once. Notice that that line has been spread out so you can't see it on the screen. It is okay to break that line up into several lines so you can see it all at once. Just make sure that everything is tabbed over correctly as you see it right here. Okay, so let's explain what's going on here. First of all, let's go back up to the first line. Remember that this first line from Visual Import star, this initialized the computer by importing all programming inside the visual module. Now, notice that when I typed all that after the pound sign is that little number sign right there, it all turned red. Anything you type after a pound sign is a comment, and the computer completely ignores that. So that's where you type human comments to yourself or to other people who read your program so they know what you were doing. This next line, the scene, this was setting up our universe. What the display function does at the beginning of this line is it sets up a box on your computer screen. We're calling this box scene. At the top of that box, in that little blue band, it's going to say my first VPython program once I run it. So whatever, and notice that the computer has turned that green, whatever you type between those quotes is going to come up literally. The computer doesn't care what it says. Over here, notice it says x equals 0, y equals 0. What these commands do is that tells the computer to put that box that we're creating in the upper left-hand corner of the screen. 0, 0 for a computer is in the upper left-hand part of the screen. We're going to make that box 600 pixels wide and 600 pixels in height. Remember, a pixel is a dot on your screen. And then this part right here where it says range, this is where we define the universe in our own units. I'm going to make a universe that is 3 meters by 3 meters by 3 meters big. Now, before we see what our universe looks like, let's put something in our universe. For this lab, we were trying to simulate a cart moving down a track. So let's make a cart. So I'm going to type cart. And a cart looks vaguely like a box. So I'm going to call this thing called an object, a cart, equal to a box. And this box is going to be positioned at, how about the center of our universe? I'm going to put 2 parentheses at the end. Let's try running this and see what it looks like so far. Now, to run a VPython program, you go up to Run. You go to Run Module. Notice you can also push F5 if you want to take a shortcut. Now notice the first time you ever try running a program, you have to save it first. So I'm going to call this Lab1. Make sure you always put a .py at the end of your program. That way the computer will know that this is a Python program, and it'll also preserve all the pretty coloring that we've been typing, that's been coming up as we type. Now also notice as we save this that when you downloaded VPython, you got a whole bunch of sample programs with it that are kind of fun to look at. Okay, so let's save this. It should now try running the program. And when it ran the program, notice that, hey, our universe pops up Sure enough, the title bar says My First VPython Program, and then there is a box in the middle of the screen. Now, if you click and hold the right button and then move the mouse around, notice that your box is indeed a 3D object. It doesn't quite look like the cart we used in lab, so let's go back and modify the program a little bit. So, here's our box. Here's a cart that we defined as a box. It's at the center of the screen. Between those two parentheses, I'm going to tell the computer a little bit about the box. First of all, I'm going to say that the height of the box is, how about 10 centimeters big? Now, the computer knows nothing about SI units or anything like that. If you look up at the previous line in our scene, notice that I said that the range of our universe is a vector that's 3 by 3 by 3 units big. What I might do is in my comment line, I might mention to people who come and read my program that this line defines my universe. Units are in SI. I remember that Martian probe that crashed because one program was written in SI units and the other was written in British Standard units. Whenever you're writing a computer program, always define your units. So we had a cart that is 10 centimeters high. It was 30 centimeters wide, so width equals 0.3, and it had a length of 0.45 meters, or 45 centimeters. And we can also give it a color if we want. Let's make our cart red. Okay, so we've made these changes to the program. If you want to, we can do what we did before and change the spacing so we can see the whole thing. Remember to make sure you indent. VPython's very particular about indenting things, and we'll talk about that a little bit more. I'm going to run the program by hitting F5. And notice that what was a box is now more of a rectangular box 3D object. And notice we can rotate around, again by clicking on the right mouse button and moving the mouse around. Or if you click both mouse buttons, you can zoom in and out. Okay. As we go back to our program, notice that we defined our object. Our object is a cart. The cart looks like a box. We now need to define some initial conditions. We need to tell the computer when time starts. Let's have time start at 0.0 seconds. Make sure that you put the 0.0 at the end. If you don't, VPython is going to think you want time to be an integer. We're going to have to take snapshots in time. This will make more sense once we make the program. Let's create this thing called dt, which we'll explain later what it is, and let's define it as 0.1 seconds. Oh, sorry. Notice that the computer has no idea what a second is. Make sure you put that pound sign so that a human will know what units you're meaning. And then we're going to define a position variable. Remember from physics that position is a vector, and we're going to have the cart start at 0.0, 0.0, 0.0, all in SI units or meters. And let's create a velocity associated with our cart. Velocity is also a vector. And let's give it an initial velocity of 2.0 meters to the right. We know it's to the right because it's in the x component of our vector there. Okay, now what we've done at this part is we've defined our initial conditions. The next part of the program is to, well, make the universe go. And we'll do that in the next YouTube video clip. And we'll do that in the next YouTube video clip.